Okay, in this presentation we're going to look at three short complex numbers calculations questions. So it's part A, part B, part C. And the first part A of this question is express this z as an integer. That gives us a bit of a clue actually that it's an integer. Okay, you might notice also that actually when you read the question and compare the two parts of the product, you might notice that there's a difference of squares in that we have 2 minus I and 2 plus I. What we'll do actually just for the time being is we'll just pretend we don't know that yet, or didn't spot it yet. So we'll just multiply out the good old fashioned way. So 2 times, so 2 times the other part is 4 plus 2i, and then minus I times the other part is minus 2i minus I squared. Okay. Quickly, you might sort of see that the two i's, the minus 2i and the plus 2i cancel each other out. Okay, so what we're left with is 4 minus I squared, and as we know, I squared is equal to minus 1. So essentially what we have here is 4 minus minus 1, and that's equal to 5. And 5 is the answer we're looking for. Okay, now this is quite an important calculation because this is used a lot in dividing binary numbers. Okay, so what you might say is that these numbers here are the complex conjugates of each other. Okay, and this sort of calculation is done quite often. Okay, so and in fact in other presentations I'm going to emphasize that directly. I'm going to not waste any time in it. So here is where I do it. Okay, multiplying a complex number by its complex conjugate. So what we're going to do here now is express the following as an integer, not as an integer. We're just going to express it. Express it in the form a plus b I. Okay, it might be an integer, it might not be. So what we're going to do is firstly just actually remark BODMAS, BODMAS. Okay, and what that means is that we divide this division here. Essentially, we're going to consider that as 3 minus I. Okay, brackets of division, multiplication, addition, subtraction. Just watch out for that. Basically, is what I'm saying. So that's quite important. It's sort of deliberately a little bit of a trap. So what we're going to do here is, well, what I'm going to do first off is just replace that with 3 minus I. Okay. And what I might also do is I just actually might, no, I'll leave it alone. So essentially what we're going to do is add everything up. So let's look at the real components here. 2 minus 4 and minus 3. Okay, so that works out to be 2 minus 4 minus 3. That works out to be minus 5. And now we look at the imaginary components there. 3i plus 3i plus 5i, and that minus I there, but watch out, that's a plus I once you consider that the minus sign there as well. So that actually works out to be 9i. Okay, that's the answer we're looking for. Okay, expressed in terms of a plus bi. So finally what we're going to do now is a multiplication. Very straightforward multiplication here. Essentially, there's no little trick here, nothing we have to sort of recognize, it's just sort of work it out. So minus 5 times the other part, there is plus 20 minus 40i, and then looking at 3i minus 12i plus 24i squared. Now 24i squared actually will work out to be minus 24. So what we have here is minus 4 minus 52i. Okay, and that's it really. So that's just a sort of quick calculation, a quick sort of bit of a practice exercise before we go into anything deeper. We'll leave it there.